Alright, so I have to attempt exercise 3.6. Write three different versions of a program to print the elements of IA. Okay, we are using type aliases to simplify pointers to multidimensional array. Okay, so we are saying that we are making a pointer to uh, an array which holds four integers, right? Alright, type aliases to simplify pointer. Okay. Alright, so let's go exercise 3.6 questions. This is exercise 3.6, and then no more exercises. Okay, so I am done with the last exercise too, I hope. Exercise 3.55. Okay, 3.6. Alright. So I have to write three different versions of a program to print the elements of IA. One version should use a range for to manage the iteration. The other two should use ordinary for loop. In one case using subscript and in another using pointers. Okay. In all three programs, write all the types directly. That is, do not use type aliases. Okay, auto tickle type to simplify the code. Okay, Micah. Okay, we got it. So this is 3.43. 3.43 dot CPP. I think that is all I need. I would have to take a look at IA. Okay, 3 comma 4. Okay, so create 3 and then 4. Okay, 3 and 4. Okay, so one version should write three different versions to print the elements of IA. Okay, so let me give it some elements. Alright, so let's go with 1, 2, 3, 4, 5, 6, 7, 8, and 9, 10, 11, 12. Okay, so there we go. 3 for the 12 elements. Okay. So I have to go write three different versions of a program to print the elements of IA. One version should use a range for to manage the iteration. Okay. So first of all, we'll go with okay. So I want a reference, right? Okay. So I'll go int. I want a reference p to an array of size arrays of which hold size 4, and then I go IA. Then I will use another reference, so this would be simple int because I'm basically printing integers, int x from p, right? And then I want to print x. So this is um, first method using a range for. Okay, let's try and make it. Huh, STD. Oh, my bad, my bad. And there we go. First one is done. Then uh, the other two should use ordinary for loop, in one case using subscripts. Oh, that should be the easiest. Okay, so this is second method using subscripts. For int I equals 0, I less than 3, I plus plus. Go for okay, getting a reference to an array which holds array which holds arrays of dimension 4. Since the elements themselves are int, we make the looping variable to be int. Okay. Second, using subscripts. This is the easiest. J equals 0, I less than 3 less than 4, then we put J plus plus, and I want to print I J okay, so this should work as well. Maybe I should add a third one using range for. Right, then I'll go method 2 using, oh, I could have used print line, right? Using subscripts. Okay, let's make this right. Then last is using pointers. Okay, so third method using pointers. Method 3 using pointers. For let me see, int pointer to array which holds we are making pointer to an array which holds arrays of size 4 equals ia. Then I want to go till pointer p is not equals to p plus 3, because those are the number of rows we have, sorry, those are the number of arrays we are holding. 3 arrays, right? P is not equals to P plus 3, okay, yeah, of the end pointer. Return the number for int q. I want to get the value of p, and I'll go while q is not equals q plus 4, so q plus plus, okay. We point to an array which holds arrays of dimensions 4, right? Now when we dereference that pointer, we will get the underlying array of size 4. So value of q nothing. Okay, so let's make it. Oh, right. Okay, should be less than, and this should be less than q plus 4. Okay, so I'll go. Okay, but does it print? Okay, it does print it. Ah, right. Okay, so it keeps on moving it further. Okay, p should be less than, I go ia plus 3, right? P should be less than ia plus 3, and q should be less than, because this is wrong because I'm using the same, right? Okay, let me try this. Okay, but this never stops, right? Okay, using pointers, we go, this should be ia plus 3, and q should be less than value of p plus 4. I think this should work. Yeah, okay. Since there are, I believe, yeah, this is done, right? ia plus 3 and value of p plus 4. There we go. Okay. If there are only 3 arrays, since there are only 3 arrays, we make sure that the pointer don't point past it, right? Since each array only holds 4 elements, we make sure make sure that it don't point out of bounds, that is base address plus 4, and then we simply print this. Okay, so we have this. Okay, rewrite the program from the previous exercise using a type alias for the type of the. Okay, so now you want type alias. ah, okay, so let's so 3.43.cpp to 3.44.cpp, right? 3.44. Let's open 3.44.cpp. Okay, I should have copied. Okay, now I have to use a type alias. Okay, I will go defining a type alias. So I'll go type def int. How does it use type alias? What do you think? Type def int. Okay, int array of star 4. That is, do not use type aliases, auto or decal type to simplify code. Okay, so this is using type aliases. A type alias. Okay, so we go def int array of size 4. Okay, so int array is an array of size 4, and we want to have a pointer to that, right? So we say rewrite the programs from previous exercise using type alias. And using says how does using int array equals int 4. Okay, new style type equivalent type def declaration. Okay, I think int array equals array of int 4. Okay, int array is int of size 4. Huh. Okay. So int array, huh? So int array, so I want a reference so I think I can go int reference of int array is in. Does that work? I think it should work. In. Invalid conversion from this to this. Okay, so int array pointer. Okay, so I go pointer of int array. Okay, sorry, this is a type. My bad. Int array reference. Int array reference p. Okay, int array reference p. Right. Okay. Okay, since int array type is an array is an array which holds some is an okay. So I go. I want a reference. I want a reference to an array. Okay. So this type can hold. Okay. So I want a reference to an uh, a type which can hold 4 integer arrays. Okay. So yeah, since the type is int array, which means any type of data that can hold uh, int arrays of size 4 size 4 we can create a pointer or reference to it. Okay, so any type of data that can hold int arrays of size 4 we can create a pointer or reference to it, right? So subscripts, I don't think there will be a lot of change in subscript. I can have it point, yeah, but then it is equivalent, right? I can say that int array reference p equals ia, then I can just go p again using the reference, and then here, okay, and then here what I can do is I can simply go, I want a pointer int array pointer reference, dereferencing. So this is another name for that, and then we dereference it here. P is not being used anywhere else right now. Okay. The value of P, yeah, P, yeah, pointer to a type which can hold, right? So this can hold, and how many of these are there? Well, we don't know. It's size. Okay. P should be less than IA plus 3, and this should work like a charm, and it didn't work like a charm. Okay. Oh, again using invalid initialization of reference type from expression 3 and 4. Oh, okay, so I can't refer to it this way. Um, what does this say? Style API. This is exactly the same. However, here I can't point it to. Okay, so int array a reference. Because not what do we say? See, int array, right? I have defined int array of 4. again using the reference, but the reference didn't really work out this way. Okay. So I am getting a reference. So pointer, okay, I can point within pointer, but this is a reference, int array reference. Hey, you know, these can be, they can be glued together. Reference, but this time it's a little different. P of I of j. Since let's say since let's say int okay, since a of 3 or 3 of a is equivalent, we can exploit that exploit that fact and create a reference to IA because okay, we create a reference to IA. Okay, so 11:30, right? Okay. So this is since reference of physical int, we can exploit that fact and create a reference to IA because int array type defines an int array of 4 defines an int array of size 4. Because int array type defines an int array of size 4, and we say that we want a reference to a type which holds again we say that we want a reference to a type which holds arrays of dimension 3 right? So this is a reference to an array which holds arrays of dimension 3, and each of these arrays dimension 3. So I could also have done 1. Would this have worked? Reference from expression of type 3 4. Right. Invalid reference of type 1 4 from expression type 3 4. Okay. We want a reference to a type which holds arrays of dimension 3. Okay, arrays of dimension 3, and each of these arrays. Okay, so there are 3 arrays, right? And each of these arrays hold stores an array for type of data. Arrays of dimension 3. Okay, if I go with 4 here, yeah, again 4 by 4, 3 by 4. Okay. This stores and type of data. So in totality we get int 3, we have 3 of int 4, which is equivalent to get type of 3. We have type, then it is an array. It is an array of dimensions 3 which can hold this, right? equivalent to a type type equivalent, we get a type equivalent to type of int 3 4, right? Okay, I get this one. We point to an array which holds dimension. The reference is a little bit can't wrap my head around that, but I get somewhat. Read the programs again, this time using auto. Okay. Okay. So we point to an array which holds arrays of dimension 4, or in this case, has a type of int array int 4. Okay. Once the pointer, we will get the underlying array. Okay. So let me copy 3.44.cpp, 3.445.cpp, 5.cpp. Okay, so I have to use auto this time. We'll go with auto. We create a reference, then we'll go with auto. and we don't be needing this. Alright, so I can't. Okay, so we create a first reference since okay, so it is mandatory that the outer it is mandatory that the outer loop variable is always a reference, and using auto because if you don't do that, you will simply get the pointer to the first array out of the three arrays, and we simply can't iterate over a pointer. We can create a pointer reference to it. Okay, so this should work. We'll worry about this later. So let's see. We have great. Okay, so I won't be using this. How do you select multiple lines? Good enough. Okay. So okay, auto. Well, I mean, in subscripts, what is the need for auto, right? If I were using iterators, rewrite the programs again, this time using auto. Okay, can I find a good of auto? Okay, there we go. Okay, of course we can add this loop with library begin, right? Auto p, yeah, there we go. Okay, the iterators begin ia and ia q value of p. Okay, auto p ia. Okay, so this is array of pointers to an int, thus pointers to an array of 4 int. With advent of the standard, we can often avoid having to write the type of a pointer using auto article type. So auto p ia not equals auto p begin. Okay, auto p ia. Okay, so this will get me a pointer. Alright, so there's nothing really for subscripts, but this will give iterator, right? Okay, so I think method using pointers, so I'll go auto p equals ia and p should not be equals to ia plus 3, we go p plus plus, and auto q is value of p, then q should not be equals to value of p plus 4, value of q plus plus, and then I can simply write value of q. Okay, so here uh, p is a p is of type Einstein p4. Then q is simply, okay, so q is simply int pointer, while p is int 4. Right, when we dereference it, we get the underlying array. Okay. This is using iterators. So I can go auto p equals std begin of ia, while p is less than std e is not equals to end of ia. You go p plus plus. Okay. Here p is the iterator to arrays of 2 and an arrays of size 4. Right, then I can go auto q equals begin, and q should be less than, q should not be equals to p q plus plus. Okay. P is of q is the iterator to an int 4 array. Okay. So when we dereference, we get the underlying array. Okay. When we dereference q, we get the int element. Okay, so it's using iterators. This is using pointers. I could have made that. Okay, let's run that. 3.45. There we go. Alright, so this is done. Then we go to chapter summary. Okay, among the most modern library types are most among the most important library types are vector and string. A string is a variable and sequence of characters, and a vector is a container of objects of a single type. Iterators allow indirect access to objects stored in a container. Iterators are used to indirect access. Iterators are used to access and navigate between the elements in strings and vectors. Arrays and pointers to array elements provide low-level analogs to the vector and string libraries. In general, the library class should be used in preference to low-level array and pointer alternatives built into language. Okay. So then we have chapter 4. Maybe I should read these ones. Okay, begin member of the string and vector. That return also I should include iterator. Member of the string and vector that returns an iterator to the first element. Also freestanding library function that takes an array and returns a pointer to the first element in the array. Okay. Okay, it don't return a pointer. Okay, so both of these are iterators. Here P is the iterator. Pointer to an arrays of size 4. Here Q is the pointer. For built-in type containers like arrays, stud begin and return pointers to the first element and past the last element in the array. So it is a pointer. Before overflow, serious programming bug that results when we use an index that is out of range for a container, such as string, vector, or array. C-style string, null terminated character array. String literals are C-style strings. C-style strings are inherently error prone. Okay, class template. A blueprint from which specific class types can be created. To use a class template, we must specify additional information. For example, to define a vector, we specify the element type vector int that holds int. Okay. Then we have compiler extension. Features that is added to the language by a particular compiler. Programs that rely on compiler extension cannot be moved easily to other compilers. Okay. Container. A type whose objects hold a collection of objects of a given type. A vector is a container. Okay. A type whose object holds collection of objects of other types. Okay. Since reference is not an object, we cannot have references. So copy initialization, form of initialization that uses an equal to. The newly created object is a copy of the given initializer. Reference type, assigned integral type defined by a vector and string that can hold the distance between any two iterators. Then we have direct initialization, form of initialization that does not include an equal to. Okay. Empty member of the string in vector returns bool, which is true if size is 0, false otherwise, and member of the string in vector that returns an off the end iterator. Also freestanding library function that takes an array and returns the pointer one past the last element. GetLine function defined in the string header that takes an iStream and a string. The function reads and stream up to the next new line, storing what it read into the string and returns the iStream The new line is read and discarded. Okay, so then we have uh, index value. Value used in the subscript operator to denote the element to retrieve from a string, vector, or array. Value used in the subscript operator to denote the element to retrieve from a string, vector, array. Instantiation compiler process that generates a specific template class or function. Okay, iterator, a type used to access and navigate among the elements of a container. An iterator arithmetic, operations on a vector or string iterator, adding or subtracting an integral value, add, and an iterator yields an iterator that many elements ahead or behind the original iterator. Subtracting one iterator from another yields a distance between the other. Yeah. Iterator must refer to the elements or the same container. Null terminated strings. Your last character is followed by a null character of the end iterator. The iterator returned by the end that refers to the non-existent element when past the end of iterator. We have pointer arithmetic. The arithmetic operations that can be applied to pointers. Pointers to arrays support the same operations as iterator arithmetic. Pointer def, machine dependent signed integral type defined in the CST-def header that is large enough to hold the difference between two pointers into the largest possible array. Okay, we have pushback. Member of vector appends member of vector appends element to the back of a vector. Range for control statement iterates through a specified collection of values. Size, member of string and vector returns the number of characters or elements respectively. Okay, return the value of the size type for the type. Okay, size to machine dependent unsigned integral defined in CSTD header that is large enough to hold the size of the largest possible array size. Name of the types defined by the string vector classes that are capable of containing the size of any string or vector respectively. Library classes that define size type defines it as an unsigned type. The string library type that represents a sequence of characters using declarations. Make a name from namespace accessible without the namespace prefix. Okay. Value initialization. Value initialization. So we have initialization in which built-in types are initialized to 0 and class types are initialized by the class default constructor. Objects of a class type can be value initialized only if the class is the default constructor. Okay, used to initialize a container elements when a size but not an element initialized is specified. Elements are initialized as a copy of this compiler generated value. Okay, vector. Library types that hold the collection of elements of a specified type. Plus operator, the iterator types endpoints. Define the increment operator to add one by moving the iterator. Subscript operator yields the element of I from the container object. Indices count from 0, the first element, up to last -1. Subscript is an object if p is a pointer and n is a synchronous is the single. Arrow operator combines the operator dereference and dot operator. Operator string library users. Okay. Let's see output operator. This is the string library type defines an input operator. The string operator reads white space to limited chunks. Okay, logical not, logical and, logical or. Okay, there we go. Then we'll move to expressions from next